Hello, welcome to this video. This is 2-6, and we are going to go ahead and learn the derivatives of the other important functions in calculus. They are listed right behind me, so they'll be there for your reference as well as in your notes here in a second, but we're going to go ahead and talk about sine and cosine derivatives as well as e to the x and natural log of x. Alright, so previously we've talked about the power rule. Now the power rule can only apply if our base is x and if the power is a constant. And I'll give you an example of this, something like x squared, x to the power of 2. Okay, so I can only use power rule for something like that. Now, we work with different types of functions where the power rule is not applicable. So we're going to go ahead and take the time to talk about those functions and see what their derivatives are. Alright, so I already talked about the types of functions that we're going to differentiate, that we're going to start incorporating into our tool belt. Sine of x, cosine of x, e to the x, and the natural log of x. Okay, so what are their derivatives? Well, the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. Not just sine of x, but negative sine of x. And at this point, I recommend drawing a quick little x and y axis. And I want you to add these annotations to your notes. Sine of x, cosine of x. Don't you guys agree this is where sine of x is 1? This is where cosine of x is 1. Now, down here at the south pole, negative sine of x is 1. And over here at pi, negative cosine of x is 1. Right? We have our sine value is -1, so negative, negative. That makes it positive 1. Here, again, cosine of x is -1, so negative cosine of x would be a positive 1. I bring this up because if you can remember this format, you can easily remember the derivatives. You don't have to really commit them to memory. Just remember this connection. So the derivative of sine of x, d dx. The derivative with respect to x of sine of x is cosine of x. Well, what's the derivative of cosine of x? Negative sine of x. What do you think the derivative of negative sine of x is? It's negative cosine of x. And, I mean, that makes sense too, because negative, the derivative of sine of x is cosine of x, so negative cosine of x. And then what's the derivative of negative cosine of x? Well, the derivative of cosine of x is negative sine x, so a negative and a negative make a positive. Wow, that's really cool. It is. Wait till January to where I bring that back and we do something different with it. Okay, so that works with sine and cosine. Now, the derivative of e to the x. E to the x. You guys know that Spider-Man meme? That's Spider-Man meme right here. The derivative of e to the x, e to the x. And I want you to do that with me. Derivative of e to the x, e to the x. You'll have that bodily reaction, always. F of x equals natural log of x. The derivative of natural log of x is 1 over x. So whatever is inside of the natural log, 1 over that. That is your derivative. Okay, there's our derivatives. Commit them to memory, or remember how you're going to remember them. Now, one thing that I totally recommend is flashcards. Use flashcards. If I want to know what the derivative of sine of x is, I would write this on one side. On the other side, I would write cosine of x. And I would quiz myself, especially if you ever wake up in the middle of the night or you're having a hard time falling asleep. Just bust out your math flashcards, okay? You'll learn. You'll start to dream about it. It'll be great, and you'll memorize your derivatives. Okay? Use flashcards. Quiz each other. If you get it right, set it down. If you don't get it right, put it back in the stack. Okay? So commit that to memory. You need to have these in your recall. Okay. We've talked about the derivatives. Now let's go ahead and apply them to some different types of functions. A. F of x is equal to 2 sine of x. They want us to find f prime of x. Okay, so f prime of x. Well, 2 times, remember multipliers come along, Derivative of sine of x is cosine of x. Done. B. F of x equals natural log of x minus cosine of x. So f prime of x, the derivative of natural log of x is 1 over x, and the derivative of cosine of x is negative sine of x. So I have two negatives, and two negatives make a positive, so I'll just clean this up. So 1 over x plus sine of x. There's f prime of x. B, or I guess, sorry, C. F of x equals e to the x minus x squared plus 7. Okay, so f prime of x, the derivative of e to the x, e to the x. The derivative of negative x squared, I'm going to use the power rule. So for negative x squared, I can use the power rule. And the derivative of 7 is 0. Done. D. F of x is equal to 1 minus sine of x plus the natural log of x over 1/3. Before we start, I really want you to see this natural log of x over 3. I would hope that you would see this as 1/3 natural log of x. That will make our computations much easier. But I'm going to go ahead and find the derivative, f prime of x. The derivative of 1 is 0. The derivative of sine of x is cosine, so I have negative cosine of x, plus the derivative of 1/3 natural log of x, that's 1/3 times 1 over x, which gives us negative cosine of x plus 1 over 3x. So there is f prime of x. If you're like my students in class today, we left it like this, and students said this, 1 over x divided by 3. And they were like, that's not the same thing. But isn't it? If I'm dividing a fraction, right, or I'm dividing a whole number into a fraction, I'm going to multiply by the reciprocal of the denominator. Isn't that 1/3? Same thing. E. Oh, I have a binomial times a binomial. Okay, well, I can't use the power rule here because I'm multiplying two things. The structure is different. So in order to go ahead and use the power rule, we haven't talked about, I'll teach you another method to do this. I'm going to just distribute this. So 2x times 6x, 2x times 2, negative 7x times 3, and negative 7 times 2. Okay, and I'll go ahead and clean this up, and we get 6x squared minus 17x minus 14. So our derivative, we get 12x minus 17. There you go. Not too shabby. Okay, F. I want to get this ready to differentiate. I have a x in the denominator, so remember that's x to the power of negative 1 plus 1/2 x plus 1/3 cosine of x minus e to the 4th. E to the 4th. That's just a constant number. That's just a constant number. They're trying to trick us there, but they're not going to trick us. Hopefully. Watch me get it wrong. Okay, power rule. I'm going to go ahead and bring down my negative. So negative x to the negative 2nd. 1/2 x, the derivative of a linear is just a constant, 1/2. Plus 1/3 times the derivative of cosine of x. The derivative of cosine is negative sine. So negative 1/3 sine of x. And then the derivative of e to the 4th is 0. So let me go ahead and clean this up. And here is our answer. There we go. Okay. So really only a couple rules that we've learned. Not too bad. They're not too complicated. Here is a practice problem. I want you to go ahead and I want you to try this one. Go ahead, pause the video, and I'll show you the answer here in a second. Okay, hopefully you went ahead and paused it. F prime of x. Negative 3 times e to the x. Well, that's negative 3 times the derivative of e to the x, which is e to the x, e to the x. Okay, plus 4 times the derivative of natural log of x, which is 1 over x. And yes, you can represent it like this, plus 4 over x. There we go. There we go. Okay, h. Whew, bringing in the radicals. Bringing in the heat. So this is 3 times x to the power 1/2. Remember, I'm just going to go ahead and I'm going to, make the radicals a fractional power. I'm going to bring x's out of the denominator into the numerator. And for our last one, we have to do both. This is negative 2 times x to the power of negative 1/2. Okay, so there's f of x. And now I will take my derivative. So 3 times 1/2 gives us 3/2 x to the power of, and I'm going to decrease that power by 1/2. Negative 4/5 x to the power of negative 3. A negative times a negative gives me a positive. 4 times 3 gives me 12. X to the power of negative 4th. And then 1/2 times negative 2 times negative 1/2 is a positive 1. X to the power of negative 3/2. So 3 over 2 x to the power of 1/2, which is the square root of x, plus 12 over 5x to the 4th, plus 1 over the square root of x cubed. Okay, so there is our answer simplified. Whoa. Okay, last one in this section. I'm going to let you try this. Go ahead, pause the video, give this one a go. If you get stuck, check back in. I'll kind of break this down. Okay, a couple of things. One, what makes this difficult is this e to the power of natural log of 1. Now, even if you didn't simplify this or break it down, which makes this problem way easier, you should just recognize that that's a constant. So, like, really, I could go ahead and rewrite this as 4 times e to the power of natural log of 1, and this is just a constant. So, like, whatever the derivative of x, right, this is just going to come along for the ride. And, of course, the derivative of x is just 1, right, times 1. So that constant comes around. Now, another way to do this, isn't natural log of 1 just 0? So 4x times e to the power of 0. And then isn't e to the 0 just 1? So this is 4x minus x to the power of negative 3. Just simplify it. It looks really ugly. Don't be afraid. It'll simplify. Okay. Go ahead, try this if you have not. I'll post the answer here in a second. All right, f prime of x is equal to 4 minus, just kidding, plus 3x to the power of negative 4. We multiply by our negative 3 power, giving us a positive 3, and then we have 3 over x to the power of 4. There's f prime of x. Okay. So you've worked with a couple of new functions. There you go. All right. I'm now going to go ahead and show how we can use graphs and tables with our other functions in order to compute derivatives. And I think this is really, really fun. So don't freak out when they give you a weird looking graph or two and then a whole bunch of tabular values. This is just information for you to use. And they say this in the example. The graphs of the functions f and g are given above along with the selected values of the function h and its derivative h prime, as well as note h double prime. Use the information above to find the following values. Okay? So I'm going to go ahead and I'm going to I'm going to take my derivative. So they say k of x is sine of x minus 3g of x plus x squared. Find k prime of 1. Well, what you have to do first is I have to go ahead and I have to find k prime. I need to know what k prime is first. And don't be freaked out. Just take it piece by piece. Sine of x. Well, the derivative of sine of x is cosine of x. The derivative of negative 3g of x. Well, I don't know exactly what g is. I mean, they have a picture of it. But the derivative of it is just g prime of x. So I'm going to include that. And then the derivative of x squared is 2x. So there's k prime. And now I want to go ahead and calculate, okay, what's k prime of 1? So cosine of 1 minus 3g prime of 1 plus 2 times 1. I just plugged in 1 wherever there was an x. Now the good news is I already have numerical answers for 2 out of the 3 terms there. I'm just missing g prime of 1. G prime of 1. I got to go ahead and compute this. So g prime of 1. I'm going to go to my graph. Here's g. Okay, where's 1? Well, 1's right here. Okay, so what's the slope at 1? So this point. Well, the slope of that line, don't I go down 1, right? Down 1, and then we run 2. So the slope at 1 is negative 1/2. Negative 1/2. So negative 1/2 plus 2. Okay, now this would suffice FRQ. You're going to stop if you had to go ahead and break this down even further. You could go ahead and simplify it into a calculator. Cosine of 1, I don't know that value off the top of my head. That's not an angle in radians, so I'm just going to leave my answer like that. All right, m of x. Okay, so I need to figure out if they want m prime of 9. I got to figure out what's m prime of x. So this gives me negative 4 over x minus, this is x to the power of 1/2. So that's going to be a negative 1/2 x to the power of negative 1/2. Okay, there's m prime of x. And then now I'm going to just plug in m prime of 9. So negative 4 over 9 minus 1 over 2 square root of 9. Okay, you could stop there. I mean, that's numerical, right? But I just feel it calling to me there. I don't feel compelled to go further than that. Okay? C. N of x is equal to h of x minus g of x plus 1. Go ahead, pause me now and try this one. Pause me now and try it. Okay, hopefully you went ahead and tried it. You had to find n prime of x first. This is equal to h prime of x minus g prime of x. And then n prime of 4. When we plug this in, we get h prime of 4 minus g prime of 4. So h prime of 4, I'm going to have to look at my table of values. Here's h prime, and I'm going to go over to 4, which is here, okay, and that value is 1. So this is 1, and now I need to go to g prime of 4. So here's g again, here's 4, and the slope on that line is just 1. So 1 minus 1, which is 0. 0 is your answer. I did all that for nothing? Yes. Yes, you did. All right, D. Okay. Woo! We're going to turn up the heat here. They give us p of x. They want p prime of 0. So again, all right, if I want p prime of 0, I better know what p prime of x is. Derivative of 7, 0. Derivative of e to the x is e to the x. So that negative comes along for the ride. And the derivative of 2h prime of x, well, I'm just going to take another derivative of it. H double prime of x, okay? So p prime of 0 is equal to negative e to the 0 plus 2 times h double prime of 0. So h double prime of 0, h double prime of 0, here's double prime, 0, that's going to be right here, 3. Let me erase these other ones so you don't get confused. Okay, So plus 2 times 3. Ooh, that was, my lights flickered. Did you see that? Okay, so we get 5. Negative 1 plus 6 gives us 5. All right. E. Q of x is equal to e cubed minus x to the power of e plus e to the power of x. Wow, they're getting really cute here. So I'm going to do, okay, q prime of x first. Derivative of e cubed is 0. Derivative of negative x to the power of e. Well, this is power rule, believe it or not. I'm going to go ahead and multiply by the power. So e times 1. And then I'm going to drop the power by 1. E minus 1. What's e minus 1? I mean, I have an idea, right? But I'm just going to leave it as is. Plus the derivative of e to the x, which is e to the x. Ooh, that was a fun one. So now they want q prime of 4. Okay, so negative e times 4 to the power of e minus 1 plus e to the power of 4. And there is our answer. Numerical, I could plug that into a calculator and get an answer, so you're good. F. Okay. R of x is equal to f of x plus 2 cosine of x minus 1 over x squared. Okay, so r prime, I got to find that first. That's f prime of x plus 2 times the derivative of cosine is negative sine of x. Okay, minus, this is x to the power of negative 2. So that's going to be a positive 2 multiplied by the power, x to the power of negative 3. Okay, and then r prime of 3, this is going to be equal to f prime of 3 minus 2 sine of 3 plus 2 over 3 cubed. Okay, almost numerical, I just need f prime of 3. F prime of 3. So I'm going up to f, here's f, and oh, that's a sharp turn, y'all. So, undefined. Your slope there is undefined. This right here, undefined. So if any of your answers composed in this function are undefined, then your whole slope is going to be undefined. So r prime of 3 is undefined. Undefined. Okay. G. Okay. S of x is f of x plus h of 1 minus natural log of x. Go ahead. I think you guys can do this one on your own. Try this one. Give it a go. Pause me. I'll show you the answer here in a second. Okay. So I'm going to go ahead and take a derivative, s prime of x. This would be f prime of x. H of 1, that's just a number. And if you went ahead and went up there and you're like, okay, h of 1, what's that number? You substitute it in. It's just a constant. So the derivative of h of 1 is 0, regardless whatever it is, right? I don't think there's any variables up here for h of 1. Now the trick, right, it's 7. So the trick here, hopefully you didn't say, okay, h, that becomes h prime of 1. So watch out for that trick. The derivative of this, right, this is just 7. What if there was a 7 there? You'd say, oh, the derivative is 0. So that disappears. Okay, and then the derivative of natural log of x is 1 over x. So there's s. Okay, so s prime now of 8, that's f prime of 8 minus 1/8. And if I go up to f, looking at 8, here's 8, our slope is negative 1. So we have negative 1 minus 1/8. Done. All right. W of x, okay. So w prime of x, find that first. Looks like we have positive 5 sine of x plus, this is 3x to the negative 1/2. So that's going to be a minus 3/2 x to the negative 3/2. All right. And then w of 4, we have 5 sine of 4 minus 3/2 square root of 4 cubed. Done. Done. Okay. It should be 64. I mean, you could take it further, right? All right, last one. Here we go. U of x. So again, u prime of x. This is just 1/3 times e to the x. So the derivative of e to the x is e to the x. Okay, minus the derivative of sine of x. That's cosine of x. And the derivative of f of x is f prime of x. So now I'm just going to go ahead and I'm going to evaluate at 1. So I'm going to plug in 1, u prime of 1, and we get 1/3 e to the power of 1 minus cosine of 1 plus f prime of 1. Okay, f prime undefined. So then if this is undefined, if f prime of 1, again here, is undefined, then all of u prime of 1 is going to be undefined. There you go. All right. In this video, you should have learned the derivatives of the other 4 important functions: sine of x, cosine of x, e to the x power, and natural log of x. We also did some work looking at using these derivatives with a function represented as another function, and how we use graphical and tabular information to find those derivatives. Give me a thumbs up if you like something or if you learned something. Subscribe for more awesome math videos. Catch you in the next one. Bye.